Hello, my name is Santiago, and welcome to 6.2 Approximating Areas with Riemann Sums. So today we're going to learn about what Riemann sums are and what they do. So Riemann sums are kind of ways that help us approximate the area underneath a curve because it's kind of very hard to approximate an area under the curve because or with calculus you can help find the actual area here. In a normal way, in normal shapes, you can calculate like the area of a square by using not one times, just base times the height. Triangle would be 1/2 times base times height. But it gets more complicated when you have more complex shapes like, I don't know, let's say an oval. If I were to make an oval, it'd be really hard to, find the area. Less, more complex shapes like something like this, it'd be very hard to find the area of a shape that looked like this. With calculus, though, we can help approximate it, and that's what Riemann sums does. So on the graph, let's just do an example. The graph of the function g of x is shown to be the right. Approximate the area under the curve on the intervals 2 to 6 with n subintervals by using the left rectangular approximation method. The left rectangular approximation method means that you start from the left and make a rectangle all the way to your your end base, and then go down. So let's just make the subintervals four subintervals, just to make it easy. From 2 to 6, 1, 2, 3, 4. I mean, 1 subinterval, 2, 3, 4. That'd be all the way to 6. So here, we'll go up, down. That's one subinterval. Up. When you meet the function, you go to the right, and you go down 2, 3, and 4 here. That's more or less what we do. That's how we would show a left Riemann sum, or approximation from the left. And the approximation method is called a Riemann sum. Sorry, Riemann sum. It was named after a German mathematician named Bernhard Riemann. So left Riemann sums, it kind of like you start from the left, you go all the way to the function, you go all the way up to the function, sorry. You go all the way up to the function. Sorry. All the way up to the function. And then you go here, go down 1, 2, and 3. Now sometimes the rectangle might be outside the curve. However, because there are rectangles that are going to be inside the curve that will be less than the function, we can kind of approximate that our mistakes from the past will help make up for our mistakes in the future, basically. And we can do the same thing from the right to the left, from 8 here, 8, 6. It's immediately on there, so it's 6. Here, boom, here to here, and here to here. By the logic of a Riemann sum, this would be the same thing as this. These are both, right ways of doing it. You're starting from the right or you're starting from the left. You go up to the function, then you go all the way to the left, and you use the intervals that they ask you. That's basically the concept, the basics of Riemann sums. This helps us, approximate the areas, and this actually helps us understand how to find the area under the curve easier. But yeah, that's basically everything for 6.2, approximating areas with Riemann sums, and I'll see you later.